Alright, since we're talking about triangles, I would be remiss if I did not talk to you guys about isosceles and equilateral triangles, because those actually arrived from the fact of attaching two congruent triangles together and then seeing what happens. Okay, so an isosceles triangle, and this is actually kind of interesting, an isosceles triangle has at least two congruent sides. So isosceles have at least two congruent sides. Okay. An equilateral have all three. Equilateral have three congruent sides. Okay. So interestingly enough, an equilateral is always going to be an isosceles because it has at least two congruent sides, but an isosceles can never be an equilateral. So that's an interesting way to think about it, that an equilateral is always going to be a type of isosceles triangle. All right, so some things we got to know about dealing with triangles, especially isosceles and equilateral. So there we go. Okay, so in an isosceles, we would call these the base angles. So I'm going to use a color for them. So base angles of an isosceles triangle are going to be these two angles, and they're always going to be, you know, subtracted from there. All right, now the base of an isosceles triangle is going to be this bad boy down here. Okay, so it's always the one side that's not congruent. Okay, and just remember the two sides, these two sides are going to be equal. Okay. All right. Corollary, not really part of a triangle, but we'll talk about it in a little bit. Okay. Legs of an isosceles triangle. Once again, let's get a different color. Okay. Legs of an isosceles triangle are going to be these guys right here. Okay, and vertex angle of an isosceles triangle is going to be this bad boy up here. Okay, so that's some pretty simple stuff. Now, if we were to label all the parts inside of a equilateral triangle, they would all look like this. So it's kind of boring. Interestingly enough, the angle is always going to be 60 in there. So that's kind of boring. You know, nothing too big, nothing too special, you know. And then we got 60 over here. Okay, so we have everything all set up. Now, if I do know this angle is like 40, okay, and I don't know these other two, you're probably thinking, wait, I need at least two angles to figure out, you know, what the size of the triangle is. Well, I do know that these are both like x's. So that's pretty simple. So I just go x plus 40 equals 180. I just set up that equation, and then I have 2x equals 140 because I subtracted 40 from both sides, and then x has to be 70. Okay, so if I just subtract that vertex angle up top from 180 and just divide it by 2, I should be able to come up with the base angles pretty easily. Okay, so that's pretty simple right there. Now, if I did want to, well, there is no specific way about going about doing it, so we're not going to talk about it. But just understand, isosceles have at least two congruent sides, equilateral have three. Okay, now corollary, let me see, I had to look up for the exact definition. A practical consequence that follows naturally. Okay, some corollaries that flow from this. You do need to understand that isosceles triangles you're going to be using quite a bit for the rest of the year. Here's some cool things about it. You can actually take a line and draw it down the middle, and you actually have two triangles that you can actually work with and stuff. So that's actually kind of cool. That's a kind of cool corollary. Another thing is that if you draw it and you make it perpendicular, bisect the base, it actually cuts these into two equal angles. So that's kind of cool. You know, that's kind of nice to know. And that always works for an isosceles triangle. Same thing here, except not as exciting. It's just blah. You know, cuts it in half, makes those two angles 30 degrees, and just works with them. Okay. All right, but that's it for an isosceles triangle and stuff. Just remember when you're working with this that these two angles are the same down here no matter what, and should be pretty simple to work with. Oh, and in actuality, there's a reason why, is because if you notice right here, let me use some yellow. Okay, I have a side, these two sides are the same. Okay, I know that this is going to be the same because of reflexive. Okay, and if I draw this line down the middle and it bisects, I know that these two sides are the same. So by SSS, I know that all of these two triangles I just made are congruent. So therefore, these two have to be congruent. So it's kind of a cool little proof to actually prove why those two angles are congruent at the bottom. Okay, all right, but that's it. I will talk to you in a little bit about congruence in right triangles. Bye.